This is question number 37 on the January 2017 Algebra 2 Regents, and this is the last question on the exam, so we can expect this one to be pretty difficult. So what we have is the speed of a tidal wave s in hundreds of miles an hour, meaning if s is 3, that's actually 300 miles an hour, can be modeled by the equation s is equal to the square root of t minus 2t plus 6, where t represents the time in hours. The question reads, algebraically determine the time, so we're looking for t, when s is 0. So that's relatively straightforward. Conceptually, what we're going to do is replace the s with a 0 and solve for t. However, solving this is actually a little bit more difficult. So what we want to do here is get the square root of t by itself, because then we could square it to undo the square root. So to do that, I'm going to add the 2t and subtract the 6 from both sides. Now that I have the square root of t by itself, I can square it, and whatever I do to one side, I must do to the other. 2t minus 6 all squared, be very careful not to just distribute this squared. What it actually means is 2t minus 6 times 2t minus 6, as the word squared would indicate. And then this side is just t, because I'm undoing the square root by squaring it. Now we FOIL this out, and we get 4t squared, 2t times 2t, minus 12t minus 12t plus 36 is equal to t. Let's simplify this equation. We have 4t squared minus 24t plus 36 is equal to t. Now this is a quadratic, and what we want to do here is make sure that we get it equal to 0 next. Some people will try to factor out a 4 here. The problem with that is that that's not going to help you in any way, because nothing is set equal to 0 yet. You would have to move the t over anyway. So what we get is 4t squared minus 25t by virtue of subtracting that t, plus 36 is equal to 0. So now we have the quadratic in the form that we need, and now we have to solve it. Our first step is to try to factor using GCF, and there's no GCF here, because now that's a negative 25, so we can't take out a 4, we can't even take out a 2. So we have to do the AC method of factoring. Because we have a number larger than 1 in the A term. Now there are a couple of other methods here. You could do trial and error here. I'm not personally a big fan of that because I don't like trial and error. But certainly if you know that method, you can use it. The method that we use here is we're going to multiply the A term times the C term. 4 times 36, and that's 144. And then we have the B term, which is negative 25. Now, in this method, you will find two numbers that multiply to 144, or add to negative 25. So you would list off some of the factors of 144, which are 144 and 1, 72 and 2, etc., etc., etc. And you could do this on the calculator as well by just trialing divisions by different numbers. The two numbers that we're looking for are 16 and 9. More specifically, negative 16 and negative 9, because we have to add up to negative 25. Now what we do is we take these two numbers and we separate the B term, the negative 25t, into a sum of those two numbers. So we have 4t squared minus 16t minus 9t plus 36 is equal to 0. And then we do factoring by grouping. So draw the vertical line here, bearing in mind that that's still a negative on the right side, and do GCF for each of the sides. The left side, we could take out a 4t and be left with t minus 4. And the right side, we could take out a negative 9 and be left with t minus 4. Now, the whole idea here is to get these two to be the same. If, for whatever reason, you end up with those two factors not being the same, you've made a mistake somewhere along this process. Because now what we can do is we can now combine these two parts, the 4t and the minus 9, into one factor. So we have 4t minus 9 times t minus 4 is equal to 0. And now we can solve both factors for t by setting each one individually equal to 0. So we have t equals 4, 4t equals 9, and t equals 9 over 4. Now, this looks pretty good, but we do have to verify that one of these is not an extraneous root. So what we now want to do is substitute both of these variables, these are both values of t, into t in the original equation to be certain that our s is indeed 0. So we have s is equal to the square root of, let's start with 4, that's the easier one, radical 4 minus 2 times 4 plus 6. We have to make sure that our s is equal to 0 in this case, because that's what we were solving for. Radical 4 is 2, minus 8, plus 6, and that does check out to be 0. So this is definitely a good answer. Now let's test the 9 over 4. We have s is equal to the square root of 9 over 4, minus 2 times 9 over 4, plus 6. The square root of 9 over 4 is 3 over 2. We could just square root the numerator and the denominator. We could simplify this, the 2 and the 4 here, by making that a 2. So we get minus 9 over 2. And then plus 6. So 3 halves minus 9 halves is negative 6 halves. That's negative 3. Plus 6, that is not equal to 0. So we have to reject this answer because it does not actually equal 0. Now, how does this happen? This happens because we end up with something called an extraneous root. The square root, for example, of 9 is 3. We don't consider negative 3 to be the square root of 9, even though negative 3 squared is indeed 9. So when we actually square both sides here, and when we square out the square root, we create an extraneous solution. 9 over 4 would work in this equation, but we're interested in the original equation. So that's that. So the answer here is going to be t equals 4. Now, you can also use the quadratic formula if you do not want to factor this. Draw a little bit of a line here. And what we have is, going back to this equation, 4t squared minus 25t plus 36 is equal to 0. Your a is 4. Your b is negative 25. Your c is 36. And yeah, we can just put all of this into the quadratic formula. X equals negative b, which would be positive 25, plus or minus the square root of b squared, negative 25 all squared, minus 4 times a times c, all over 2 times 4. Now, you've got some fairly large numbers here, but we can certainly figure these out. So, let's work with the inside of the square root first. Negative 25 squared, you could just put in 25 squared, it would be the same thing. Minus 4 times 4 times 36. And we get 49. So x is equal to 25 plus or minus the square root of 49 over 8. Well, the square root of 49 is 7. So 25 plus or minus 7 over 8. Now split that into your two answers. We've got 25 plus 7 over 8, which is 32 over 8. And that is 4. So our t is 4. Remember, it's x, but we're really solving for t here. And 25 minus 7 over 8, which would be 18 over 8, which is 9/4. So t is equal to 9/4. And you would still have to go through the process of rejecting this answer and only accepting t equals 4. So that doesn't change. This just helps you solve for those solutions in a different way. Either way is perfectly fine as long as you remember to test the solutions at the end for the rejection. There is a common mistake that students make when inputting this into their calculator, and it's actually just this. If you put in negative 25 squared, but you don't put the negative 25 in parentheses, what the calculator will do is square root of 25 first and then give you a negative answer. That's obviously a problem because we're actually trying to square negative 25, so just be careful with that, or just don't input the negative. Since you're raising it to the second power, you should know that that's going to be a positive solution. So I just wanted to point that out. That is something that students make mistakes on with some frequency. Okay, the second question is, how much faster was the tidal wave traveling after 1 hour than 3 hours to the nearest mile per hour? So how much faster would be the difference in the speed. So here we're looking for the speed at t equals 1. And here we're looking for the speed at t equals 3. And how much faster is the difference between the two. So our equation is still s is equivalent to the square root of t minus 2t plus 6. Well, we want the answer when t is equal to 1, and we want the answer when t is equal to 3. So s is the square root of 1 minus 2 times 1 plus 6. That's 1 minus 2 plus 6. That's going to be 5. Now, you do have to remember here, this is in hundreds of miles per hour. So this actually represents the speed of 500 miles per hour. The second one here is going to be the square root of 3 minus 2 times 3 plus 6. Now, we cannot actually get the square root of 3 mentally here, so we have to use the calculator. What we're going to get is the square root of 3. That's 1.732, and that's about as far as you really need to go. So 1.732 minus 6 plus 6, so we get 1.732, and again, that's in hundreds of miles per hour, so we're going to multiply it by 100 just as we did here, and what we get here is 173.2. Now the answer is calling for to the nearest mile per hour, so that's fine. We'll just round that out at the end. So now it says how much faster, so all we do is do 500 minus 173.2, and we get 326.8, which will round to 327 mph faster. You could just as well have rounded it here to 173, and you would have gotten this answer right away. Either way is perfectly fine.